Hello everyone, this is Carrie with Everwood Creations. Today, we're going to talk in depth about V-carving with your CNC. I'll give an explanation as to what V-carving actually is, and then show how to go about it in the Vectric VCarve software. I'll be using Vectric VCarve Pro version 9.5, so if you're using an older or newer version, things may be a bit different for you. Let's start at the beginning. What exactly is V-carving? A CNC can be programmed to use different bits for its carving. A traditional profile path is meant to be carved with an end mill, making a square cut into the material along the lines specified in the software, resulting in a two-dimensional carving. V-carving, on the other hand, uses an end mill with a sharpened edge that comes to a point and carves in a V shape. The traditional squared-off carving is now cut at an angle, creating what is known as 2.5 dimension carving. The angled cutting comes with a different set of rules than a regular end mill and uses its own toolpath controls in the software. Typically, when creating a toolpath, you tell the machine what line to follow and exactly how deep to carve. But V-carving is different. I will now answer the most asked question about V-carving in general. How do I set the depth of my V-carve toolpath? The short answer is, you don't. The software determines the depth of the cut based on the width of your vector. More detail on that later. While end mills come in different sizes like 1/2 inch or 1/4 inch, V-bit sizing is done by the degree of the angle of its sides. The two most standard V-bit sizes are 60 degree and 90 degree. The common 60 degree V-bit will offer a sharper angle and gives more depth to your cuts, while the 90 degree is a softer angle with wider cuts and less depth. V-carving is an excellent choice for making signs. You can check out our start to finish V-carve sign tutorial linked in the description below. V-carving lends itself well to carving text, allowing more detail in the lettering. Look at the difference in these text carvings. The top one is carved with a typical end mill, while the bottom one is done by V-carving. Not only are you adding dimension by having the slanted edges, you are also able to do much more intricate carving. In this example, you can see the end mill wasn't able to reproduce this font at all. The text would have to be much, much bigger. But with V-carving, the font is created flawlessly with a lot of depth and flourish. Now the question you may be asking is, but why? Why can V-carve do such intricate things? Well, that depth that we talked about earlier is the true secret behind V-carving. When you V-carve a vector, the depth is determined by how far into the material the V-bit has to plunge in order to make a cut of that width. If you have a nice wide width, the V-bit will plunge all the way into the material. But if you have a narrow vector, like with some of these fancier fonts, the bit will only plunge to the depth on the V-bit to make a cut of that size. Now that we understand the process of V-carving a little better, let's look at the toolpath used to create it in our software. The toolpath bar is located over here on the right. If you don't see it, look for a tab over here. If your tab keeps closing, this little pin will keep it open all the time. In your Toolpaths panel, the top row under Toolpath Operations contains all the 2D toolpath options. The next row contains the 2.5D toolpaths, beginning with VCarve here, which is what we are looking for. If you open the VCarve toolpath panel, you will see all the ways you can customize your carving. First, we have cutting depths. The start depth will typically be 0.0 unless you are V-carving on top of an area that has already been reduced by a previous toolpath, in which case you would enter the depth that has already been carved here. So if you have a pocket that was carved 0.1 inches deep, you would put that value here, letting the software know where the new top of the material is. The next value is flat depth. This offers you a solution if you have a vector so wide that it would plunge through the material if V-carved normally. You can also use a flat depth value to make sure your material maintains a certain thickness under the carving, which is good for maintaining strength or double-sided carving. The flat depth allows you to keep the 2.5D look without restricting you to certain widths in your vectors. Here you see 3 stars that are all V-carved, but the size of the bigger stars caused the V-bit to plunge all the way through the material. Obviously, this is not generally what we are looking for, so that is when the flat depth option comes into play. A flat depth tells the software the maximum depth you are willing to let the V-bit plunge, and flattens out the carving at that depth. You can see in these illustrations the different pathing the bit takes with a flat depth. Here you can see the same stars, only this time I set a flat depth at 0.5 inches. You can turn the flat depth on and off by clicking the checkbox here, though a value must be entered in the box if it is turned on. Next we have the Tool menu, where you can tell the software what size of bit you are using by selecting one of the existing tools under V-bits, or by manually entering a new tool. Using the Edit button allows you to make changes to the tool for this toolpath only, leaving the settings in the tool database as they were. Next, you can select whether you want to use a flat area clearance tool. This allows you to clear out large areas with a larger end mill before cutting the smaller details. If I select to carve this star with a 1/4 inch end mill first, you see that it creates 2 paths with the same name. One that has the end mill icon and says pocket behind it. This is the clearance path. The other has the V-bit icon and is the finishing path. Just previewing the clearance path, you can see that it leaves little stair-step edges for the V-bit to easily cut through. Then I can preview the actual V-carve path and it smooths out those edges. Keep in mind that doing this requires a tool change in between. The next panel allows you to change the carving direction or pattern of the clearance tool. You are also able to select whether you want the end mill to ramp into the material. While clearance tools are often used for 3D toolpaths, I find I don't use it as often with V-carving. It's just not necessary. If you aren't planning on using it, just leave this box unchecked to turn off this whole section. Next, you can tell the machine if you want it to carve the shapes in a particular order. Use vector start points will begin the carving with the starting node of your vector. If you aren't sure where the starting node is, select the vector and go into node editing mode. The little box that is green designates the starting point of the vector. If you wish to change the starting point, you can simply hover over the box you want to be the new starting point, right-click, and select Make Starting Point. Or you can just hit the P key and it will automatically change it to the starting point. Similarly, you can tell the machine to carve in the order you select the vectors. This allows you to determine the order in which the individual shapes are carved. If you don't select either of these options, the software will optimize the file for the quickest machining time. Next, the panel tells you the currently set safe Z and home position. If these need to be changed, you will need to do it in the Material Setup panel. You can also choose to project your VCarve onto a 3D model. Checking this box will cause the software to calculate the depth of the 3D model you select and carve into the surface, even if it is not flat. For example, I have a 3D apple here, and I would like to carve the words #1 teacher on the surface. If I just make a normal VCarve toolpath, it doesn't carve properly in the 3D carving. By using the feature that projects the toolpath, it carves perfectly across the uneven design. Next, you have the option to have the software automatically select the vectors to be carved. This is useful if you are creating or importing templates, but in general, you will probably want to manually select which vectors the toolpath carves. Finally, you enter a name for your toolpath here. Naming helps you keep track of which toolpaths are which in the software, but otherwise serve no purpose for the actual carving. And that's all there is to creating a VCarve toolpath in the Vectric software. I hope you found this overview helpful. VCarving is a very valuable tool for anyone with a CNC, and a must for carving text. As always, if you have any questions, feel free to leave them in the comments below. Like and subscribe if you find value in our content, and until next time, have fun and stay safe in the shop.